So for today's video, I'm going to talk about how you are able to get input from your camera like this, and also how you're able to use one single file to launch two cameras at the same time. So let me begin close everything. So first thing we want to do is we want to get a camera feed working in our PC. So to do that, the first thing we want to have is you can do a sudo apt install ROS magnetic and UVC camera. Hit enter, type your password. So for me, I already installed. So if you have not installed this, install. And then after this, what you can do is you can plug in a camera onto your PC and then type a command roslaunch UVC camera and then hit tap on your keyboard, and then you will see there has 5 different launch files on here. So we are going to talk about this for later on. Today we are going to focus on the first guy, camera load.launch. So here we have camera load.launch file. So roslaunch UVC camera load.launch. Hit enter, and then by default it should not give you any error, and it should just give you a bunch of the message showing up here. So the next thing I want you to do is you can do a roslaunch hours. So we can use this visualization tool to see all the image you just created. So by the way, so here I'm using the shortcut here by topic, so you can see all the topics being generated, all the corresponding stuff. So here we're going to use image, or you can just do it this way. By display type, you can choose the image, and you can change the topic on here, image topic. So both of these have the same effect. So let me just remove all of this. So here, right now, the camera you are seeing here is actually the camera from my PC. So here's one camera working. So how is this launch file here able to get you the camera feed you want? So let's dive into that. So let's open up the Visual Studio Code, and then you can go to the file and then go to add folder to workspace, and then you can go to other location, computer, sorry I go too far, computer, and then OPT, and then ROS, and then magnetic, and then go and then just click on OK. So OPT, ROS, magnetic, add. So once you add, you can see on the left side here, you can see this folder called magnetic. So under here they have two folders. Two folders is the most important one. The first one is called lib. This folder, it contains all the compile file of each individual package. So it's like the low level stuff, the executable file. So and in the share folder is where the high level stuff contained, like the launch file. I'm going to talk about more later. So go to the share folder and then scroll down, try to looking for the package we just installed here, which is called UVC camera here. Actually, before we move on, so here as you can see, here has a bunch of different folders like TurtleBox 3, which is what we installed before, and then you can see here they have the like ROS CPP, which is the library if you are using the C++ to write the ROS. Also here has a ROS message, which is all the like the string, integer, all the ROS message type. And also we can have a bunch of other stuff, like let's say action lib, which is hosts all the library for the action. So all here is actually all the package you install by using the doing here by using the sudo apt install ROS magnetic. So whatever the package you install here is actually going to install into this folder, this magnetic folder, and it's going to pull the high level file into the share and low level executable file into the lib folder. Okay, so let's move on to our package. So here, go to the share folder, and then go to the UVC camera, and then under here you can see a launch folder, and then under launch you can see the camera load.launch, which is what we just launched over the terminal here. So let me close this so you can see it. So let me hit up. Sorry, excuse me. So sorry. So here you can see a roslaunch, and then UVC camera, which is the package name, and then the camera load.launch, which is this launch file here, camera load.launch. So inside here, the structure of the launch file is you need to start with the tag called launch, and then inside the launch you will have a load tag, which indicate the load name of which file you want to execute. Do you remember earlier when we do the assignment like the publish and subscriber, we have the code, we need to use the rospy dot initial load or something. Let me pull up here. So just pull out one of those. So earlier when we write the code here, you need to write this line right here. So rospy dot initial load and something. So in the load, in this launch file here, this load is going to search for this type of the single file, and then here this is the package name, this is the file name, and the name here is the load name, which is where you initialize, like this guy, where you initialize inside your script. So here the output will be the log message of this entire file. Let's say if this file will give you some kind error or a warning message, where do you want it to output? So output equal to screen, that means whatever message is going to output in here in the terminal, like this. So here it has all the log file, it has all the warning message, so all the stuff going to the screen terminal. So again, here the first one is the package name, second one is the file name. So here the UVC camera node, so this file is actually contained inside the, let me scroll to the top, so magnetic, the lib, so go to the lib folder here, 1 second. So go to a lib folder here and then scroll down, you can also see a folder called UVC camera, and then under here we have a UVC camera node. So this file is a C++ compile file, that's why you are not able to display anything inside the editor. So here you're going to call this package, and then going to call this file, this compile file, and then you're going to initiate the load equal to UVC camera. In terms of that, it will be something like this: initiate this guy to load, and then output the debug message to the screen. So later inside here, they have different parameters you can pass into your script here. So here they have different parameters like the width of the camera, the height, FPS, the frame rate, and autofocus, and a bunch of stuff. In here, what we want to pay attention is this line right here, the device parameter. So in here, you're going to define which device you are going to use for this launch file. By default, it's going to be a video 0. So if you have a webcam inside your system, this video 0 might switch to your webcam, or it will just by default using the camera on your laptop. it depends. So yeah, this is all about the launch file. So next we want to able to write our custom launch file inside our ROS package. So to do that, we can scroll up to the top and then go to our ROS package. For me, which is this guy, ROS workspace. You can just go to wherever the ROS workspace in your PC, and then go to the SRC, and then go to the your package. My package name is solution. For you, maybe the beginner tutorial or whatever other name you give to your package. So go to the package, and then right now I already have this folder called launch. If you don't have this folder, just right click on new folder, give a name called launch. Okay, since I already have it, so I just escape. So create a launch folder under your package, and then right click on here, and then create a new file. And then for me, I'm just going to call camera test.launch. The name of this file doesn't matter. The most important part is this guy, the extension. You need to use .launch to let the system know this is a launch file. So after this, hit enter, and then I need you to go back to the list magnetic, go to the share folder, and then scroll down to the UVC camera, and then go to the launch, find the camera node.launch, and then copy the whatever is inside here, and then go to the file you just created, the camera test.launch, and then paste into here. So the next thing we want to do is, since right now we actually just create our first custom launch file inside our own package. So next thing we want to do is we need to compile our package, the workspace, ROS workspace, in order to use this launch file. So to do that, we can, let me close everything I have here. So this is my workspace. I'm just going to do the cat king make to compile. After compile, do the source dev setup.bash, hit enter. So now the system knows all the stuff I have inside this workspace. So next we want to do a roslaunch, and my package name is solution. So solution, my file name is camera test. So I'm going to call camera test.launch. I hit enter, it should just show exactly the output as what we have before. So next we want to do the roslaunch hours. So add the image, changing the topic, image raw. So here you can see my ugly face here. So everything is working perfect. So one thing to notice here is usually when we talk about running the ROS command, we need to first run something called ROS call, which going to be the center of your all the executable file. This is going to be your ROS master. But in here, we actually didn't run the ROS call. We just directly run the roslaunch something. The reason behind that is when you run the roslaunch inside the ROS system, it actually has a mechanism. Is the roslaunch is going to include the ROS call inside there. So you're going first to check the whole system if the ROS call is running or not. If the ROS call is not running, then when you run the roslaunch, it's actually going to run a ROS call for you. So basically, when you're running this guy, it's going to check the whole system, see, okay, is there any ROS call running? This guy, no. So it's going to just launch a ROS call inside this script. Just something it comes with the roslaunch, but it doesn't come with the roslaunch. So this is really important. So the roslaunch, it comes with a ROS call. roslaunch, it doesn't. roslaunch is always going to looking for a ROS call, but it will not create a ROS call. Okay, so here, since we are able to get the camera to working, so next we want to move on to have two camera we are going to get a two camera feed inside our one launch file. The way to do that, first we want to check how many cameras inside our system. To do that, you can do let me clean this up. Do a ROS, which is going to list all the file inside certain like the folder. So ROS DEV, which I'm going to check all the file inside the DEV folder. I'm going to check the video file especially. So when you type the video and then hit tab, it should give you a pop out saying like video 0, 1, 2, 3, 4, 5. So in my case, actually, right now I have two cameras plugged into my system. So the first camera here, the video 0, is the camera from my PC. And then there has a video 4. This one is a camera from the webcam I just plugged into my system. So right now I'm going to remove the webcam from my system. And then I'm going to do the same command here. And then do tab. As you can see here, it only showed me 3 different video files, which the video 0 still be my webcam on my laptop, but the video 4 and 5 is disappeared just because I unplugged the webcam. And also one thing, I'm not really sure why, but when you plug into your webcam, you actually will get 2 video files inside here. But only the first one, the video 4, is the actual source of your camera file. So what I mean by that is, let me plug in my webcam and then do a tab so you can see the video 4 and 5 again. And next we are going to go to the launch file we created before and then change the video 0 to, let's say, video 4. So when we launch this thing again and then do the roslaunch hours, add our image, and here you can see this is another camera from webcam. So let me just point it this way so you can see this is additional camera. So let me close this. And then next, let me change something. As you notice here, when I plug into the camera, you actually have like 2 different stuff. One is video 4, one is video 5. So if you're going to type a video 5 here on the device option and launch this command again, it will actually give you an error because only the video 4 is the source of your camera feed. So if for some reason when you type in like the video 0 or 1 or 2, whatever the number you type in there, it doesn't give you like a clean output without error. Just try a different number. Well, if you have a camera device on your system, one of the video file is going to be work. So like for me, LSDV video tab. So here I have like 5 different not camera, 5 different video files. So if any of this number like 1, 2, 3 is not working on here, so you just try a different number, try all the number, then eventually there's one will give you the correct video output. So next we're going to talk about how I'm able to get a video feed from both the camera on my laptop and the camera from the webcam. So the way to do that is you can get this load, copy this guy, and then paste the same stuff here. So what I just do here is basically the load tag here is actually indicate the executable, like the compile file here inside the lib folder. So basically what I do here is going to launch 2 instances of our UVC camera load file. And here there's two things really important. First is the name of this load. So as we mentioned before, each ROS load need to be unique. They cannot be two loads have the same name. So first thing, we need to change the bottom one maybe to a UVC camera -1. And then next we want to do is we want to give a different device source for these two files. So the first one, I'm going to get video 0, which is the video output from my camera on my laptop. The second file, I'm going to give a video 4, which is the webcam plugging into my laptop. So next we have one additional problem is since this tool is running exactly the same file, which is UVC camera load file is this guy. So that means they are going to publish to the exactly same topic. So a way to avoid that is you can remap the topic to a different one. What I mean by that is you can just go to Google, search for ROS launch file remap. So the first one here, you can see the remap example here. If you want to learn more, you can just read through this short documentation. He will have more detailed explanation of what each parameter means here. So I'm going to copy paste this command to the second node here, remap from, the from which is the topic name of our image file. In our case will be called image raw. This is by default published by this file here. So we're going to remap this topic to image raw and then -1. So right now we have two exactly same instance of UVC camera load file running, but with two different node name and two different camera source and two different image topic. So this one will be image raw -1 and this one will be just image raw. So save this and then go back to our terminal and then launch the same command, roslaunch solution camera test.launch, enter, and it shouldn't give you any error on your PC. So next we're going to run roslaunch others. So here click on add and then you can add image and then change the topic name called image raw. So as you can see here we have two different topics. So for this guy I'm going to just call image raw here and then just hit enter. Next we're going to add another image which is going to change the topic name to image raw 1, which is going to be a webcam here on the side. This guy. We're just going to see here. So there you are. You have two camera sources running on the system, but you only launch with one single file here. And yeah, actually this is it about how to use a launch file and how to get a source input from your PC.